Hello, everyone. My name is Kelly Hall. I'm a marketing coordinator for ALS in North America. I want to thank you all for joining us today for our webinar Wednesday. Our presenter today is Darlene Stastny, representing our laboratory in Waterloo, Ontario. Darlene has a wealth of experience and expertise in the industry, working with ALS as a business development representative. Her commitment to client service, combined with her technical expertise and experience, make her a valued partner for ALS clients. Today, Darlene is presenting an overview of the air quality testing capabilities of our Waterloo laboratory. For any questions throughout the presentation, feel free to either write in a question or add a question to the chat box or even raise your hand. Darlene, thank you for taking your time to deliver this presentation, and I will go ahead and turn it over to you.
Thanks very much, Kelly. I wanted to thank everyone for joining us today, and I appreciate that you are all taking your time to see what ALS has to offer with respect to air quality testing. I wanted to preface the presentation with the fact that although this is an overview of our Waterloo capabilities, that we do have a vast amount of capability across our network, and if what you're looking for in air testing isn't presented in this particular presentation, please feel free to contact any of your account managers or myself. My email address will be at the end, and ask us about any type of air testing that you are looking for, and we will do our best to match you up with one of the capabilities within ALS. Waterloo air quality testing includes the items listed here. We currently focus a lot of our time on doing the soil gas testing, as well as doing our thermal desorption tube analysis for both active and passive testing. So the active testing would be doing indoor air or outdoor air on thermal desorption tubes, whereas the passive testing for thermal desorption would be your fenceline monitoring. Canister work would be your soil gas, your sub-slab, your indoor, as well as indoor air and ambient soil vapor intrusion as well, and stack emissions. We also have capabilities to do testing for LEED and well green building, as well as looking at greenhouse gas ozone precursors, your landfill and pollution control plant monitoring. So those would be your fixed gases and your sulfur gases. The equipment that we currently use are the silica coated canisters. So they're selenite coated. The difference between this and the traditional, what would have been called sumid canisters, is the sumid canisters are electropolished. And while they're still very much in use in the industry, they have a tendency to have certain VOC compounds stick to the walls of the canister, which is why often when the cans are sent out, there's a slight amount of moisture put inside them to keep the walls moist, to stop compounds from sticking to them. Sulfur compounds are really sticky as well. The selenite coated canisters are inert, and we found this product very superior when it comes to looking at any type of compounds in there, whether it be the sulfur compounds or VOCs. And we've gone to using them as well as our quick connects. And the quick connect advantage is that you have a very small dead air space, as opposed to what was formerly in the swage lock. While you don't have the control to be loosening or tightening the swage lock fittings, which you would have normally done with a wrench, you do have the ease of not having to use a wrench at all, and the quick connects are simply a attach, click, and you're actually taking a sample. Thermal desorption tubes, we have two kinds: active, which includes 3 types of sorbent inside, a weak, a medium, and a strong adsorber, or passive, which is a single sorbent. The Tedlar bags are still used often for leak testing, so helium analysis, but we also send them out with our siloxane kits. We would send out a Tedlar bag, and we would send out a thermal desorption tube as well as a syringe, so that the sample can be taken out of the PET bag and deposited onto the thermal desorption tube, and this also extends the hold time of the samples. We do not receive a lot of Tedlar bags for actual sample analysis anymore in Waterloo, and that a lot of that has to do with the hold time. Hold time is only 24 to 48 hours. If we receive it in a can or on a tube, it immediately extends the hold time. So the shortest hold time would be for things like sulfur compounds, where you would have about a 7-day hold time in a canister, where only 24 to 48 hours in a bag. So it really does make a big difference. Plus, there's less chance of sample escaping. It's a sealed unit within a canister. The Tedlar bag still does have some leakage, and when it's shipped, sometimes pressure causes the bags to, again, lose sample in them, or out of them, pardon me. DNPH treated cartridges, whether it be as passive or active, are used for formaldehyde. We currently also test for hexavalent chrome. This is on filters that are used in stack sampling, and we're also doing filters for particulate. This is just an idea of the instrumentation that we currently have in-house, and just demonstrates the fact that we do have redundancy, not only redundancy within our Waterloo lab in order to be able to accommodate testing, and if there's an instrument down, we have a backup, but we also have this across the network, and ALS prides itself on being able to utilize our network to provide backup, so that, for example, our Vancouver lab has also a thermal desorption instrument to do TD tubes, and our Edmonton lab has various air testing capabilities to provide backup and to support all of our analysis efforts. This is what our instrumentation looks like for the canister analysis. It's a GC instrumentation, and you can see the canister there. We actually have the system connected to what we call a Christmas tree, which has the quick connect connections on it, and the canisters can be attached to that. Samples are then drawn and can be identified by the location on the Christmas tree that they are attached to, the canisters attached to draw a sample into the instrumentation for analysis. And it really is a state-of-the-art piece of equipment, and we have found that it works extremely well. I'd spoken a little bit before about the quick connects, but this is what they look like. We've installed them not just on our 6-liter cans, but also our 1.4s and our bottle vacs. Now, our bottle vacs are something fairly new to the industry. They work great for samples that are high in concentration. So, for example, your sulfur samples, sulfur gases, often there's high concentration of sulfur gases, or your landfill gases. And so in order to not contaminate a can or spend copious amounts of hours trying to keep a can clean, we encourage clients to use the 1-liter bottle vacs. The technology is exactly the same. They are selenite coated. The glass is a little bit thicker, although they look just like a plain 1-liter amber. They really are a specially selenite coated bottle, and they have the hardware attached on top. The advantage for the client is that if there's any moisture getting into it, you can actually see that inside the bottle. So that does add an additional feature for the client to be able to see if there's anything getting in there. And finally, as a lab, we enjoy the capability of, although these are still fairly costly, they're about a quarter of the cost of a canister. So the 1.4-liter canister is nominally about $600 to replace one. The 1-liter amber bottles with the hardware about $140. If we cannot get the bottle cleaned, we can take the hardware off the top and then dispose of the bottle. So they do provide a distinct advantage that way as well. They still go through exactly the same cleaning process. We proof them the same way we would the canisters, so they are, for all intents and purposes, a canister. Just to show you the difference between the canister system and the thermal desorption tube system, this is what the system for our tubes looks like. We have 2 of these currently. What we do is we would take the thermal desorption tubes, which are the steel tubes that you see mounted there, and when we send them out, they have brass caps on the ends of them. We take those off and replace those with the Teflon caps that you see there for the analysis. So our active tubes are used for sampling with a pump, and it contain the 3 different sorbents. So your weak, your strong, and your strongest adsorbent. The tubes are marked, and really, when these tubes are used, they are wonderful for situations where there is some moisture because they are hydrophobic, And they are also great for driving down detection limits. So if you're looking for lower reporting limits, as long as you know which VOCs you're trying to target and which VOCs are present, because there are safe sampling volumes for certain VOCs, with the limiter being vinyl chloride, about 10 liters onto the tube. This really is a terrific low detection limit. The tubes are thermally desorbed, so they are essentially, when they come to the instrument, they are thermally stripped, and our recovery is incredible in these, in that it's greater than 80%. So it really does give us a great picture of being able to, or a great opportunity to be able to give you very accurate and precise data and with low reporting limits. Really, when it comes to canisters and thermal desorption tubes, you're looking at complementary techniques. And that in itself, because the canisters are good for your low molecular weight VOCs, the thermal desorption tubes are greater for your higher molecular weight VOCs. For a canister, you simply connect the quick connect flow controller on the top, and you're taking a sample, and you would take a whole air sample. For your thermal desorption tube, you would connect a pump. You would still be calibrating the tube, and we do provide a calibration tube with the order that you would get. You get good recovery of polar VOCs on this. It is a smaller size, so when you're looking at canisters versus tubes going to remote locations, you can ship a small amount of canisters in a cooler, where you can put a large number of tubes in a cooler. The limiting factor for the tubes would be having the sampling pumps. And for passive sampling, the tubes are wonderful. They are deployed for 2 weeks at a time. They are brought back in with the new tubes deployed at the same time, and sent to the lab for analysis. We do track both canister and tube with what analysis they are required to be done on, and as well, we also look at what contaminants are found in the canisters and tubes, and we do keep track of that. For the tubes, we have a responsibility for our fenceline monitoring program to track them cradle to grave, and we also have to track how long it's been since they've been conditioned before they're deployed. That is also a time limit, so I think it's 30 days. We tag the canisters when they are sent out to a client, so that you can actually see what they are good for as far as sampling. For example, you would get a specifically low-proof canister for looking at indoor air or health-based indoor air testing, whereas if you're doing soil vapor, you would get a canister specifically for that particular use. If we get a canister back and we have trouble with the VOC levels trying to get it clean again, what we would do is we could use that canister for fixed gases, because there would be no conflict there, and we could still use it for fixed gas analysis, and that is why we tag them. When you're asking for canisters or thermal desorption tubes or any type of air equipment, it's critical for us to ask the following 3 questions. And the first one is, what type of air are you sampling? The second one is, how long are you sampling for? And the third is, what type of criteria are you looking to meet? That helps us make sure that we're providing you the right equipment and you're going to get the right data in the end, because getting the right equipment is absolutely critical. If you have a look here on this slide, you can see the variations even in criteria from province to province and federal. So it really is critical for us to have that information so that we can get the proper equipment to you and get you the right data in the end. The indoor air, the concerns that currently are often attributed to new equipment, new furniture, carpets, building materials, can also be analyzed or sampled for by our equipment using either thermal desorption tubes or canisters. If you are targeting something specific, and again, you're aware of the concentrations, the thermal desorption tubes can either be used active or passive, the passive being maybe a little less intrusive. And if the VOCs that you're looking for can be analyzed on the tube, then it may be the best way to go, and then using a passive dosimeter for the formaldehyde. This allows the least amount of intrusion and gets you the most information as far as data is concerned, so that if there has to be something targeted further on, you can do that. For ambient air monitoring, all of the equipment that we've described so far can all be used and is applicable in different situations. So the fence line monitoring, which is a passive technique, we would use the thermal desorption tubes in a shelter, and these tubes are good down to about minus 15 degrees C. The bottle vacs would be great for looking at landfill, gas, or tank head or stack emissions. Possibly linking with a stack emission if there's heat associated with that, putting in a knockout or an impinger to cool the air down and take out some of the moisture. For the sulfur and sulfur-related compounds, ALS currently can do 22 different compounds, and I will show you those in a subsequent slide. Here are some of the applications that would be useful when you're looking at sulfur and sulfur gases, as well as some of the fixed gases. So your methane, your carbon dioxide, your carbon monoxide, your nitrogen, your oxygen. The instrumentation that we are using for sulfur analysis is our sulfur chemiluminescence detector on a GC. And the reason that we've picked this instrumentation, because there are others out there in the market, is because it is specific, sensitive, and accurate. And we are able to provide a wide range of compounds on this, as well as analyzing a wide range of matrices or types of air, as noted below, the ambient air, the indoor air, as well as your landfill gases. Here's the list I was speaking about earlier, 22 compounds that for sulfur. There are 6 compounds there that are highlighted that, in fact, at this point, we are doing below the ambient air quality criteria that falls under Ontario Reg 419. As you can see, although these are all sulfur compounds, you'll also note that there are mercaptans in this list and thiophenes. So we are providing a wide range of compounds in our sulfur list. That being said, if you simply want TRS or H2S, we can provide that also. So again, for us, looking at what you need or want reported is the most critical. When you look at costing, our costing for air isn't cumulative. So if one compound is $120, 2 is not $240. So it's really important for us to know what you're looking for, how many compounds you need, and then we can provide you the best possible cost and the best possible information. The new regulation that is currently in the proposal stage, it has been out on the Gazette as of last May, and we are waiting for it to be promulgated, is based on EPA Reg 325 out of the US. It's a passive technique for fence line monitoring. It would require the facility to put up fence line monitors along the perimeter on the posts. The monitors look somewhat, or they're also called shelters, look like an end cap from a sewer end cap, and they have a holder inside. They're mounted onto a post, and the holder inside can hold up to 4 thermal desorption tubes. Under the proposed regulation, a minimum of 12 would be required, and they can be put radially or equidistant on the perimeter, and that is outlined in the proposed regulation. It's important to note that the compounds that are currently being proposed for this federal regulation are benzene, 1,3-butadiene, and TVOC. The sampling time would start in April and would end at about the 22nd of December. 20 sampling events, so every 2 weeks tubes would be deployed and at the same time replaced with the old tubes come out, the new ones go in. And after a period of 19 sampling events, the 1,3-butadiene, if it comes back below criteria, could then be decreased in sampling frequency down to once every 6 months. In Ontario, this is currently already regulated for a number of facilities down in the Sarnia area. We are currently working with 5 facilities there, and we are also working with a facility out on the East Coast with the fence line monitoring and the thermal desorption tubes. Some of these facilities have opted to do the full scope of VOCs that we are capable of, and I will show you that in a subsequent slide. And that is in order to get ready for what we believe will be an identification requirement, or what the regulation is leading to because of the TVOC. the TVOC is generally a catch-all and will show worst-case scenario, but I believe that some of the facilities are starting to look at what in that particular TVOC group, which is literally just a total number, would be their target compounds. We are required to provide additional QC for this program currently. We've started with this in 2016, and then in 2017 participated in a collaborative program that ran 6 months. Most of the facilities have continued to run their programs past this every 2 weeks. The key for the clients has been the additional QC, as well as all the record keeping. Everything is done and provided for them in Excel. A number of facilities have employed consultants to do this for them, and then we have one facility who has had a consultant set it up, but is actually doing their own inputting of the tubes and removing of the tubes and submitting the data, and then they have somebody on staff who then looks at the results and puts the data into spreadsheets for them. Tubes are tracked through the lab, and we provide those at a rental or rental and cleaning cost. So essentially the cost that we associate with the tubes is to clean them and to track all the information on them, because that is a requirement under this regulation. And this is just reiterating what I've just said. The initial date that this regulation was supposed to come into effect was coming into effect January 1, with the deployment of samples starting July 1. My contact at Environment Canada has indicated that this is going to be coming out in early fall, and that being the case, because there is a off period from January until the end of March, it would be likely that the program would start in the spring. And again, as I had mentioned before, these are the compounds that would be of interest, and a minimum of 12 sampling points per facility. It is based on the size of the facility and also on the shape of it, with any kind of obstructions or items that would be interfering be taken into consideration as to whether your monitoring stations or your shelters would be equidistant or whether they would have to shift. And the plan has to be put in for this, and that was done by the facilities that are currently monitoring. So a plan was put in based on their actual facilities and where they were proposing to put their fence line monitors. This is the principle that the passive sampling works on. So the samples, or the tubes sit in a shelter, and the air diffuses across the surface of a diffusion cap, and then the material is adsorbed onto the sorbent inside, which is Carbopac X. The limiting factor for the lab would be the uptake rates for the VOC. So if we have an uptake rate for the VOC compound, then it isn't in all likelihood that we can provide that analysis. And again, we'll show you the list of compounds that we're currently validated for and that we have uptake rates for. If one of our clients would be interested in another VOC compound and we can establish or have an uptake rate for that, we can certainly look at adding additional compounds to our list for client-specific requests. So as I'd mentioned before, the Carbopac X is a hydrophobic material and does work for a broad range of VOCs. So here it gives you an indication. So from the very volatile to the SVOC, but SVOC, the limiting compound in all would be your naphthalene. I don't think that we would go much heavier than that at this particular point. However, that being said, if another through the manufacturer, if other compounds are validated or set up, it's certainly something that we can look at. And here's the list of compounds that we're currently able to do. And for the Environment Canada project that we were working on the East Coast, we were reporting all of these compounds every time. So they were interested in looking at every single one of these compounds. And on the right-hand side there, you can see what a shelter looks like mounted onto a fence. The height that these are mounted at is anywhere between 1.5 and 3 meters. And that is not so much limited by the fact that of wind or airflow, as much as it's limited by the fact of accessibility. So if there's an opportunity for the public to be able to get at these, it maybe put them a little higher, whereas if they are just sitting on the fence line and there is really no other public access, then the employee that's coming to switch them out, then putting them a little lower may work a little easier. Just as an FYI, we have had this project ongoing with a First Nations group, and they did have them mounted at just under 2 meters, and we had no loss of tubes in that particular program, so there were no issues at all with the tubes being absconded with. Excuse me. The most common testing that we are currently doing for or on canisters tends to be the petroleum hydrocarbons, and so that is sometimes the VOC list under TO15 that we currently do with, which includes about 68 compounds. However, we are also providing the petroleum hydrocarbons F1 and F2, as well as subfractionation. And the subfractionation is based on both the Atlanta, what was the Rebecca or RBCA, and the BCMOE air methods. And so we can provide these additional subfractionations for the clients if they so desire. Chlorinated compounds are often kept or are often thought of or correlated with dry cleaning facilities. That they certainly are found in other other industries as well, but generally when we think of chlorinated compounds, we think of dry cleaners. The main compounds are PCE and TCE. However, what is important to know is that because these solvents are considered recalcitrant, so they can't be broken down by bacteria but through biodegradation. The actual breakdown products are more hazardous, and they're listed at the bottom there than the parent products themselves, and that is why they are heavily monitored. Our fixed gases, and we talked a little bit about these when I showed you the slide about sulfur and sulfur compounds. So most of the time we think of fixed gases commonly with landfill gas or looking at energy from waste facilities, but their CO2-O2 ratio can also be used to look at the biodegradability of hydrocarbons in soil, or if there's a probe seal leaking. So it's important to note that the use is not simply for landfill, but there are some other uses for fixed gases and fixed gas testing. Siloxanes, for us, siloxanes, when you look at this analysis, would be sent out in the kit that I had indicated earlier with the syringe, with a thermal desorption tube, and with a Tedlar bag. And the reason that we ask that the sample be drawn out of the Tedlar bag and put onto the syringe is to extend hold time. When you're looking at siloxanes and collecting them in a Tedlar bag, it's because the outlets on the systems generally only allow for that connection for the Tedlar bag to be attached. And so in order to facilitate that, that is how we provide it. Siloxanes tend to be a hazardous material that act similar to what sandblasting would, but this on industrial equipment that you would find in landfill or energy from waste or waste burning facilities. So it's really important that these are monitored on a regular basis. And as noted there on the bottom, the biogas industry has some pretty strict limits on the amount of siloxanes that are permitted to be in burned methane gas. So the thermal desorption tube works really well for that, to collect the samples, and we can provide both the cyclic and the linear siloxanes in our analysis. For formaldehyde, we can do both passive and active, and I've mentioned that they can be done on lead. For anyone who isn't familiar with the Well Green building, this is something that we were introduced fairly recently. This has come to us out of the US, and not only does it include air testing, but it also includes well water testing in coinciding with this particular program. So Well Green building is more of a whole scope, not just looking at indoor air, but also looking at the drinking water systems that are included in a facility. So we do provide this testing, and it is done out of our Waterloo location, but also our Simi Valley location in California provides this testing. And then the sampling is collected either on the DNPH cartridge, either passive or active, and these cartridges need to be kept cold. That is the one key thing. They need to be frozen before we send them to you, and we ask that they be shipped on ice to send them back, and that just makes sure that the compounds remain stable. And that brings us to the end of my presentation. I wanted to thank you all for taking time to listen to our presentation and to go through some of the capabilities that we have across ALS and specifically at the Waterloo location. On this particular slide, I've included the contacts at some of our various locations, as well as mine at the very bottom. If you need to contact any of us, or if you're looking for a lab close to you for air testing, please feel free to contact us at any time. Thank you very much.
Thank you, Darlene. We can now open it up for questions. You can either do that by raising your hand or by typing in a question or via the chat, and we'll go ahead and ask Darlene those questions. So we'll go ahead and wait a couple minutes just so everyone can write down their questions and send them in. Still no questions as of right now. We'll give them a couple more minutes in case anyone does have something they want to ask. But I did want to say a big thank you to everyone for attending this webinar Wednesday today. This recording has been recorded and it will be posted on our YouTube channel. All they need to do is search the ALS Limited to find our channel and then click on the North America playlist. There you will find a wide range of video resources and past Webinar Wednesday presentations. Also, you can follow our showcase page on LinkedIn as well as other various forms of social media. We will post links to future webinars and other valuable resources there too. Still no questions or no hand raises. We'll give it a couple more moments. Well, Darlene, it does not look like we have any questions. As she had mentioned earlier, feel free to contact anyone at on this contact page for any additional questions you have about this presentation or any ALS. Oh, it looks like we do have one question, Darlene, from Troy. He asks, in using passive VOC sampling, do they require SUMA canister testing for verification?
No, they don't. Not at this time.
Perfect.
And I guess I should elaborate a little bit on that further. As far as the passive testing is concerned with the TD tubes, the Ministry of the Environment and Climate Change in Ontario ran a project out of the Sarnia area at the petrochemical refineries and at the petrochemical producers using canisters. That was their initial project, and then they've moved from there since to the passive thermal desorption tube monitoring.
Thank you.
Does that answer your question?
There was no follow-up question, so I think so. Oh, he says yes.
Okay.
All right. Well, I want to say thank you again to Darlene for hosting this webinar Wednesday today and for everyone in attendance. Everyone just enjoy the rest of your week.